Welcome to qnawire.
So in this case, the reading on E is going to equal the mass of the beaker plus the mass of the liquid plus of the mass of the liquid that is displaced by the block. So here we know the reading on E is 7.5 kilograms, and then the mass of the beaker is 1 kilogram plus the mass of the liquid 1.5 kilograms. And then plus the mass of the liquid being displaced would be equal to the density of this liquid times the volume of the liquid, 0.0038 meters cubed. And at this point, we can say that the density of this liquid is simply going to be 7.5 minus 1 minus 1.5, all divided by 0.0038. And the density of this liquid is found to be 1,236.84 kilograms per cubic meter. This would be the answer for part A. So for part B, however, we need to first find the mass of the blocks. So the reading on D is simply going to be equal to the mass of the block plus the mass of the liquid being displaced as well. So we know the reading on D is 3.5 kilograms. We know the mass of a block. Rather, we need to find the mass of the block, and then we have the mass of the liquid being displaced. We know the, right here, this mass of the liquid being displaced, we know is going to be the density of the liquid and the volume of the liquid being displaced. Here, it's going to be our 1,236.84 times our 0.0038. Solving for this, we know that the mass of the block is going to be 8.197 kilograms. So, and then the question for part B asks us, okay, what is going to be the reading on scale D if block A is released, if block A is pulled? So if block A is pulled, the reading on D will simply equal the mass of the block. And this is going to be, of course, again, 8.197 kilograms. If the block A is pulled, the reading on E is actually going to just be the mass of the beaker plus the mass of the liquid. And in this case, this is going to be 1 plus 1.5, 2.5 kilograms. So these actually will be the readings if A is pulled, and then we found the density of the liquid in part A. And that's the end of the solution. Thank you for watching.